V.E.R.A V01 is live, 10 episodes of TOGAF Architecture. Here is what we actually shipped. Not a white paper, a working demonstration, 5 modules, a CD corpus, a passing test suite, the Krampitz Analyser, the Formula Parser, the E-verification service, the V.E.R.A pipeline, and a demo script that processes a real query through the complete logic chain and exits with a structured provenance chain. Frontier reasoning models still hallucinate more than one query in 10, not because of training failures, because standard predicate logic has no existence requirement. V.E.R.A does. The code is GPL-3.0, on GitHub. Arc 2 begins next week, with D-service and a 500-drug pharmaceutical corpus. Given all of that, what is the minimum viable verification?
Let's get into it.
Welcome to the Hamberger report. Project V.E.R.A. I'm Andreas Hamberger. V.E.R.A started with a single claim: AI hallucination is not a training problem and not a scale problem. It is a logical architecture problem. Standard predicate logic conflates existence with predication. A model can generate grammatically correct, semantically coherent statements about entities that do not exist, because nothing in the logic requires an entity to exist before properties are attributed to it. Non-traditional predication theory, developed by Professor Horst Wessel at Humboldt University Berlin and formalized in the Krampitz rules published in 1990, solves this by mathematically separating existence from predication. The E operator requires that an entity exists before any property is predicated of it. The separation is deterministic. It is verifiable. It is not probabilistic. 10 episodes, 10 ADM phases, 1 architecture. The design work is done. V.E.R.A V01 is 5 working modules, a CD corpus, and a passing test suite. The Krampitz Analyser implements the 9 Krampitz rules. These govern specific classes of claim rules about existence, identity, negation, and how properties are attributed to entities. The Formula Parser converts natural language assertions into the formal logical structure the Krampitz Analyser processes. This is the translation boundary between prose and logic. The E-verification service checks the E-corpus. Is there a verified existence record for this entity? If the record is absent, the claim fails existence verification before predication is ever attempted. No existence, no predication. That is the rule. The V.E.R.A pipeline orchestrates all 3 layers in sequence and exits with a structured provenance chain, and the demonstration script is a working, end-to-end example of V.E.R.A processing a real query through the complete pipeline, not a white paper, not a proof of concept. A working demonstration. 3 signals from early 2026 clarify where V.E.R.A sits in the landscape. OpenAI acquired Promptfoo on the 9th of March 2026. More than 127 Fortune 500 companies were already testing AI outputs against defined criteria. Output verification is now considered infrastructure grade by one of the largest AI organizations in the world. Vectara's HHM 2.3 measured frontier reasoning models in March 2026 and found a hallucination rate exceeding 10%, not a 2022 problem, a right now problem. And a March 2026 ArXiv paper demonstrated Z3 formal verification, achieving 100% accuracy across 135 test cases on structured problem sets. Here is the distinction that matters. Promptfoo asks whether an AI output is correct. V.E.R.A asks whether the reasoning that produced it was logically valid. Output testing catches wrong answers. Reasoning verification catches wrong logic. They are not competitors. They are layers. Most AI verification products are output classifiers. They assess a model's response. Is this harmful? Is this factually consistent? Does this align with defined criteria? These are valuable functions. They operate at the output layer. V.E.R.A operates at the reasoning layer, below the output, using the EM separation. Before any predication is generated, existence verification is required. Consider the query: is aspirin effective for managing fever? Under V.E.R.A operation, its architecture, aspirin must first resolve to a verified entity in the E-corpus. Only then can properties, effectiveness, application, dosage range be predicated. a language model generating a plausible drug interaction for a compound that has no verified existence record, is not making a grammatical error or a semantic error. It is making an existence error. Standard output testing is not designed to detect this. BCG's research from March 2026 found that human oversight of AI systems hits a practical ceiling at around 4 or more concurrent AI tools. This is why the 170 millisecond latency target set as a design decision in episode 6 remains the architecture's governing constraint. Verification must sit inside existing response latency, invisible to the user. An architecture that requires a separate human review step is not an architecture, it is a hope. The 10 episodes produced more than working code and an architecture diagram. They produced a governance trail. A TOGAF architecture description does not just define what a system does. It defines why each architectural decision was made, what alternatives were considered, what the trade-offs were, and what the implications of each decision are for system evolution. V.E.R.A, this architecture is documented at that level across all ADM phases. Every component has a rationale. Every interface has a formal contract. Every risk is logged. This matters for Arc 2. No architectural decisions need to be relitigated. When Arc 2 extends the architecture with D-service, the indiscernibility relations that handle identity resolution, the extension fits into a defined architecture rather than accreting on top of an undocumented system. The OECD due diligence guidance for responsible AI provides the regulatory frame that makes V.E.R.A legible to enterprise and government audiences. V.E.R.A.'s provenance chain aligns with the guidance's tracking requirements. The governance case rests on a documented architecture that can be audited, not on a product claim that cannot. Episode 12 begins the coding arc. The working title is The Identity Problem. The technical focus is D-Service V0. 1. Implementing the 4 indiscernibility relations that govern when 2 differently named entities are in fact the same entity. The concrete demonstration will be pharmaceutical. Is Panadol the same entity as paracetamol? Without D-Service, a verification system that encounters a query about Panadol cannot use its paracetamol verification records, and vice versa. With D4 resolution, the system correctly identifies them as indiscernible and applies the relevant existence and predication records to both names. This is not a contrived example. It is the central identity problem in pharmaceutical AI verification. The stakes are clear. These are medications. The entities are well defined. WHO data exists. And the identity resolution problem is genuinely hard. Episodes 12 through 16 complete Arc 2 and deliver V.E.R.A V02 D-Service, a 500 drug corpus, a FastAPI wrapper, a Claude integration layer, and a side-by-side demonstration of what V.E.R.A catches that an unverified language model misses. V.E.R.A is GPL 3.0. The code is available on GitHub. This is a deliberate choice with a deliberate rationale. Open source projects survive not because of their licensing terms, but because they produce working code on a defined timeline, and working code attracts contributors. V.E.R.A has working code, it has a timeline, it has an unsolved problem, claim extraction, that is genuinely hard and academically interesting. Researchers working on formal logic, natural language processing, and AI verification will find a working code base to build on, not a concept paper to respond to. The proprietary element is not the architecture is open. The proprietary element is the e-corpora verified entity coverage in specialist domains. A pharmaceutical firm, a legal organization, or a government agency that needs verified entity coverage for their specific domain will need a corpus built to their requirements. That is where T-Porno's commercial model sits. The engine is shared. The domain-specific fuel is not. The architecture is done. The first release is in the world. Arc 2 begins next week. Given that frontier reasoning models still hallucinate more than one query in 10, what is the minimum viable verification layer you would demand before trusting an AI agent to act on your behalf? That is the Hamberger report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.
like and subscribe.